Alrighty, so in this experiment, right, our goal, of course, is that we're going to isolate the components of actually a three-component mixture. So in today's lab, and I'm going to try and do this in terms of a table, you're provided, of course, with a mixture, and that mixture contains calcium carbonate. It also contains, of course, salt, which is just table salt, sodium chloride, and sand. And once we get into nomenclature in class, right, you're going to realize, of course, that, of course, the chemical formula for sand is SiO2, that is silicon dioxide. Now, we've talked about mixtures, right, prior to this experiment. So just as a reminder, remember now we look at the classification, of course, of matter. What did we say? Well, that first category, right, when we look at the subdivisions, of course, we had what? All matters were either what? Pure substances. So all the materials around us were either pure substances or they were mixtures, right? If it's a pure substance, we said what? Well, those can either be what? Your elements or your compounds. But for today's lab, we're focusing, of course, on mixtures. And so we noted that our mixtures, of course, hopefully you recall this information, our mixtures are either homogeneous or our mixtures, of course, could be heterogeneous. What do I mean by this? Well, do not forget, of course, that your mixtures always contain what? Well, they always contain two or more substances. But then you should also recall the fact that these substances, of course, right, could be in any possible, of course, combination. And so your mixtures also have what is said to be what? Variable composition. So for today, you actually have no idea how much calcium carbonate, how much salt or sand is in my mixture, but you know for certain that this mixture contains, in this case, 3 compounds. And so our goal, of course, is to realize that when we're talking about mixtures, it doesn't really matter if it's homogeneous or heterogeneous, but we can actually, of course, what? We can then go ahead, of course, and isolate each component. Now, a few things, just, of course, for vocabulary. If it's a homogeneous mixture, what did we note? We note, of course, that these mixtures are completely uniform. And when your mixtures, of course, are heterogeneous, then they're non-uniform. When it's uniform, it just means it has a single phase. And if it has a single phase, of course, it means that you cannot identify what? The salt molecules, for example, than the water molecules. And so one good example of a homogeneous mixture, right, is salt and water. An excellent example for a heterogeneous mixture is, of course, sand and water. But no matter what, I need for you to recall the fact that we said in class is that our mixtures can be, of course, separated, and this can actually be done by what? By physical means. And so you're familiar, right, with several physical means of separation. One, of course, is extraction. The second, of course, is evaporation. We've also discussed decantation, right? And 4, filtration. These are 4 possible, of course, means of separation that is actually, of course, right, done, of course, in an introductory chemistry laboratory. And please note, these are all, right, physical means of separation. However, in today's lab, we're actually going to be performing one possible chemical means of separation when we're trying to isolate calcium carbonate. As I proceed throughout this experiment, I'm going to take a few minutes, right, to make sure that I expand on each of these means of separation. But just, of course, to begin, right, what do I mean by the term extraction versus evaporation, decantation, and filtration? And so, as we said, of course, in class, when this technique involves extraction, what am I doing? Well, usually, of course, you're adding some solvent to remove, right, a soluble component. So, for example, if I have a mixture of sand, let's say, of course, and salt, I can add water, right, and what's going to happen? The water is, of course, what? Water will dissolve, of course, the salt, and so I can extract, of course, right, the salt with H2O. Likewise, if I have a container of salt, of course, and water, do you guys agree? I can actually recover the salt by doing what? Just, of course, by heating, of course, that mixture. And what are you going to notice? Well, the water will evaporate, right? That's a process of evaporation. And, of course, we can then recover the salt. Decantation, fairly simple. It just means, of course, we're pouring off. We're going to be using this technique as well throughout the experiment. And, of course, finally, filtration. In filtration, of course, this requires, of course, what? A setup that involves, of course, a funnel, a porous, of course, filter paper. Don't forget, I'm going to be talking about a few terms here. You'll hear me mention, of course, the terms residue. This is the material, of course, that remains on that filter paper. The filtrate, of course, right, is a solution, of course, that goes through that paper. Alrighty, so what's the first thing we're going to do in today's lab? So in today's lab, our goal will be, don't forget, to determine what? The percentage of calcium carbonate at the end, the percentage of salt at the end, and the percentage of sand. So how can we do this? Well, to determine the percentage, right, what do I need to know? Well, at the end of today's experiment, you will need to know what? The mass of calcium carbonate. So you need to know the mass of each component in that mixture. And what am I going to divide that by for the percentage? Well, it's going to be the total. So as we go through this experiment, it's going to be extremely important that you know the total mass of your mixture. And so because this is a percentage, what do I need to do? I need to times that by what? 100. And I'm going to repeat that, right? You guys agree? I'm going to repeat that for not just calcium carbonate, but I'm going to repeat that, of course, for NaCl. So it's going to be the mass, of course, of NaCl over the total mass of my mixture. And again, times 100. And for sand, it's going to be finally the mass of sand that we obtain over the total mass, I hope you're able to see this, of my mixture. And of course, times 100. Okay. Alrighty, so I'm just going to take a few minutes and quickly walk you through this experiment so you know exactly when we're using these physical means of separation. And so the first step today will be first to add, right, 50 mLs of water. Now, please note, here it really doesn't matter if I add 50 or 49 mLs, but we're adding approximately 50 mLs of water. So why are we doing that? Well, the reality, of course, is that one of my components will dissolve, of course, in water, and therefore that means, of course, of separation is referred to, of course, as what? Extraction. And so what are you going to note? Well, when my salt dissolves in water, I'm going to end up with a solution, do you guys agree, that contains what? Salt and water. Later, of course, in chemistry, you're going to see me oftentimes write that as an aqueous solution. That means, of course, my ionic compound is in water. This will be, of course, my filtrate, because that is going to go through the filter paper. My residue, however, is going to be what? Will be, of course, my other two components. It's going to be calcium carbonate and, of course, sand. Now, I can determine the exact mass of salt in my container. How? Well, I can take that filtrate, I'm going to place it, of course, on a hot plate, and I'm going to allow this to heat up. That process is known as what? Evaporation, therefore, will occur. So the water will evaporate, and I'm going to be left with just solid, right? Do you guys agree? Sodium chloride. We can obtain the mass of that solid. I can compare that to my initial mass of my mixture and find the percentage, of course, of salt. Now, the challenge, of course, is how will I separate these two? And so please note, right, I now have, of course, what? A filter paper, right, which, of course, here's the residue. I'm going to actually transfer this residue to what is called, of course, an evaporating dish, and I'll point it out to you later. However, I still need to isolate, right, those two components. And so here's where, of course, our chemical reaction will occur. We're going to be adding HCl, of course, to this. And what do you think is going to happen? Well, if you recall, of course, in that report, right, calcium carbonate, which is a white solid, it will react, of course, with hydrochloric acid. And what you should, and I know we have not done balancing equations as yet, so I'm just giving this to you. There's no need for you to worry about if you need to balance this or not, but I need for you to understand the chemical reaction that's occurring. We're going to generate what? This will produce calcium chloride. It's an aqueous solution. And of course, notice, of course, a gas will, of course, evaporate in the process, CO2 and water. Later, you're going to see, of course, in chemistry that whenever I have a carbonate, carbonates react with acids. It doesn't have to be HCl. It could be any acid. we always form, of course, a salt, CO2, and H2O liquid. And so when I do, of course, add the HCl, what's going to happen? Well, I'm going to end up, of course, with what? A solution of calcium chloride. And great, I finally have what? Just my sand alone, right? In this section here, of course, I'm just going to decant. This is just going to be a decantation. So I'm going to pour off my calcium chloride solution, and I'm going to be left, of course, right, with sand. In chemistry, we want to make sure, right, that we remove all the HCl molecules, right, that's around. And so you're going to hear me talking about that we're going to actually wash, right, or sand. But no, here I have calcium chloride. I don't need calcium chloride. What do we need? I actually need what? Calcium carbonate. And so the final step in this experiment will be for me to recover, right, the calcium carbonate. And so an additional chemical reaction will occur. So I'm going to take my calcium chloride solution. We're going to add potassium carbonate to that. And this will regenerate back, of course, please note, calcium carbonate. It's going to regenerate back my solid calcium carbonate and, of course, right, KCl. Later when we get to our solubility rules, right, this is literally using, of course, or the facts of solubility. All potassium salts are soluble. I could have used sodium carbonate as well. All sodium salts are soluble. But I will recover the calcium carbonate. Again, here we will filter, right, and of course dry. Now, a few problems in this experiment. We want to make sure at the end, right, to find what? The percentage of each component. So do you guys agree? Our samples must be what? Completely dry. So this is going to be a major degree source of error. Because there's a good chance, of course, that of course these components will not be completely dry. And so my total percentage, or at least when you guys do your calculations, could be greater than 100% as we proceed. I also want you to think about this as I do this experiment. Which component do you think, right, was the most difficult for me to isolate? So also, of course, check as I proceed to see, was it the most difficult to recover the sodium chloride, or was it sand or calcium carbonate? So let's move on, of course, to the experiment, right, for today. Alrighty, so in this experiment, right, you're provided with a mixture, and I've placed the mixture here so you realize, and you may not be able to see this directly, but this, of course, is a heterogeneous mixture of calcium carbonate, sand, right, silicon dioxide, and of course salt, NaCl. And so the goal, hopefully, at the end, as we mentioned, is to determine what? Both the mass of salt, the mass of sand, and the mass of silicon dioxide, right, at the end. So here, of course, are the solutions that we'll need, right? So we'll need water. We'll also need, of course, HCl. This is, of course, hydrochloric acid. It's actually, of course, extremely corrosive. It's a 3 molar solution. That just represents the concentration of our solution. And then we also need a solution, of course, of potassium carbonate, which we'll need later, to recover, of course, right, our calcium carbonate. So these are the solutions required for the experiment. In addition to that, of course, we're going to be using several unique glassware. So we'll need, of course, an evaporating dish when it's time for us to dry the sand. We'll also need, of course, a watch glass when it comes time, of course, for us to dry, of course, our calcium carbonate solution. And initially, of course, here's my setup, right, for the filtration. Here we'll need, of course, an iron ring, a stand, right, and our wonderful, of course, funnel. Inside that funnel, you're going to see later, I'm going to be placing my fluted, of course, filter paper. And for me to get to that point, right, to flute this paper, all we do, of course, in the laboratory is that I fold this first in half, then I go ahead then and I fold it again in quarters. And of course, then I will just remove, right, 1/4 of that and place it directly, right, in my funnel. Oops, my funnel is pretty large. But to keep that in place, you're going to see later, I'm going to add a few drops of water to that funnel to hold it in place. Alrighty, so for our experiment. So if you're reading along with me, right, or if you've read this prior, so you could answer those pre-lab questions, you'll need to recognize that I'll need, 2 beakers. Beaker 1, right, and beaker 2. So let me just go ahead and give you, of course, the information, right, that you'll need. You'll need to know the mass of each of these containers. So the mass of beaker 1 is 111.494 grams. This is beaker 1. And for beaker number 2, again, you'll see, of course, that the masses are different, right? Depending, of course, on the manufacturer. This mass, of course, is 93 for beaker 2, 93.979 grams. The experiment calls for me to add, of course, what? My mixture now. So here's my mixture. And I just lied about that. This is not my pre-weighed mixture. The experiment calls for me to add my mixture to my container, and then to record the mass, and I did this earlier, and to record the mass, of course, of beaker 1 and my mixture. So my mixture was initially, right, I already pre-weighed this, and I determined the mass. So in, of course, your notes, please make a note. The mass of beaker 1 plus my mixture is 114.091 grams. So 114.091 grams. So what do I now have? I have my mixture, and the goal, of course, right, is to begin isolating my components. So in step number 1, the experiment calls for me to do what? To add 50 mLs, of course, of water. So now again, why am I doing this? Because, of course, what? Don't forget we said what? That NaCl is the only component, right, that is water soluble. So when I add, of course, H2O, what's going to happen? It's actually going to what? It's going to be used, of course, to extract that soluble component, right? Salt. I want to keep on mixing for a while to make sure, of course, that all the salt dissolves. But you notice, of course, that the solution does not appear to be what? Clear and colorless. Why not? But not only do I have sand, which probably, of course, you can probably see at the bottom, but I also have what? Calcium carbonate. It's almost like chalk, right? And so that's why that solution, right, appears to be, of course, cloudy, because calcium carbonate, of course, is a white, of course, powder. So once, of course, my the salt has completely dissolved, and I should honestly stir this for maybe a minute or two. So just give us a minute. I'm going to then move over, right, and what? And filter my solution. Please note, what I'm going to be using, of course, right, to collect my filtrate is beaker number 2. Remember, you already have the mass, right, of beaker number 2. So what's going to be in beaker number 2 as I run this experiment? Well, of course, once I add, of course, my mixture, right, the salt water, right, that's my filtrate, will be, of course, be collected in beaker number 2. So I'm stirring along just to make sure that all the salt, right, completely dissolves. Alrighty, so this should be wonderful. So what I'm going to do next, I'm going to use, of course, this is just a water bottle. This is just distilled water. I'm going to use that, of course, add a few drops of water to hold my filter paper in place. I don't need it to be moving all over. This will not affect my results. Do you guys all agree? Because it's just water, and of course, don't forget, we just used water, right, as our solvent earlier. So here's, of course, our beautiful technique for filtration. So I'm going to try to avoid adding any of the solid initially, because I want, of course, my filtrate, right, to go through my porous paper. And I hope this funnel is not too large for this. Alright. So right now I'm adding, of course, my solution. And so you should be able to hopefully note, of course, right, that my filtrate is going through that porous paper. It's being collected, of course, in beaker number 2. Likewise, at the end, you're going to notice, of course, right, that my sand and my calcium carbonate will hopefully be on that filter paper. We always want to make sure that we don't add too much solvent at a time, nor do I want to add any of the solid initially to clog that paper. Now, if the solution that exits is not clear and colorless, I will certainly know that I have a problem, right? And that there's probably a hole in that filter paper. Now, why do I say this? Well, do not forget, right, that NaCl, when it dissolves in water, is just a clear, colorless solution. So if this is cloudy, then I know, oops, there is a bit of calcium carbonate, right? That of course is transferred into my filtrate. But I think for right now, we're in excellent shape. It is still just a clear color solution, just salt and water. And all I'm doing right now is that I'm just adding, of course, the remainder of my solution to, of course, the filtrate, the setup. Never rush. You just have to be patient as we do these experiments. Alrighty, so once we, of course, we've added most of the solution and we're at the end, we just want to come over and use, of course, our wash bottle just to tilt it at an angle to make sure that we remove all possible residue. So don't forget, of course, we do have that residue, that calcium carbonate, right, and sand. And so you should notice at the end, now that this beaker looks fairly clean, I've removed all residue, and so I have my filtrate. And hopefully in a few minutes, of course, this will stop and I should be able to, of course, also be able to show you, of course, the residue on that paper. Alrighty, so what we're going to do next, right, is that I'm going to remove the filter paper with, of course, the residue. I'm going to take, of course, also remove, of course, my beaker. Don't forget, now this is beaker 2 with my salt water solution. I'm going to place that directly on my hot plate. We'll allow that to boil while we move on. And what do you think is going to happen? The water will evaporate, don't forget. And of course, we'll be left just with salt. I'm going to then open, of course, my fluted paper. And on that paper, right, you should be able to observe, right, our residue. The residue, of course, is just a mixture of our calcium carbonate, right, along, of course, with sand. And so with the aid of water, I'm going to transfer that residue to, of course, our evaporating dish. I want to use this not too much water because at the end, of course, I'm going to have to pour off, which what do I mean by that? That means, of course, I just have to decant, right, the H2O. But I need to be careful and make sure that I remove, right, all of my solid. So you can still see a small amount, right, of the calcium carbonate, but I'm using the water in my wash bottle to remove, right, all of the solid. Beautiful. Once that is done, I can then go ahead, of course, and discard my paper. So I will not need this paper moving forward, so I can discard this paper. I'm going to allow, of course, that solution to settle. And what I'll do next, of course, is that I'm going to pour off. I'm going to try my best to pour off only, of course, the water. And, of course, the residue, calcium carbonate, and, of course, sand will then remain, of course, right, in my, of course, evaporated dish. So I'm going to grab another container just to pour off that solution. But I'm letting it settle for a few minutes because I'm trying my best to avoid, of course, removing any of the calcium carbonate. Maybe now the sand will transfer over when I decant, but in this part of the experiment, of course, that solution, no matter how hard you try, you're going to see calcium carbonate is a bit challenging, of course, to recover. Careful as possible, I'm going to decant, and all I mean by that is to pour off, right, the water, and hopefully what's remaining, right, will just be sand and calcium carbonate. But if you notice, right, that the water is a bit cloudy, so therefore what does that indicate? That indicates, right, do you guys agree? That unfortunately, right, we're losing some of the calcium carbonate. So that's oftentimes the most difficult for us to recover. Alrighty. So now, inside my, of course, evaporating dish, we have, of course, what? Calcium carbonate, right? Just a small amount of calcium carbonate, right? It's a white powder and sand. And so in my next step, now this is no longer a physical means of separation. This is now going to be what? A chemical means of separation. So I'm using one of the chemical properties, right, of calcium carbonate to actually, of course, separate or isolate those two components. So this would involve adding what? 8 mLs of hydrochloric acid. Now I'd be very careful as I add, of course, the hydrochloric acid. And why is that? Because when hydrochloric acid reacts with carbonates, what do we produce? We produce the gas, of course, right? CO2. So I want to make sure that there's no splattering. So it's very important that we add this slowly. But not only do I need to add this slowly, right? I also need to mix. So you will see, of course, right, that the gas is released because you see that fizzing. That just indicates the evolution of the gas CO2. Notice, of course, that that white powder is also being converted, right, to that aqueous solution, right? So you see, of course, that the white solid calcium carbonate is being converted to our calcium chloride solution. Now, when the reaction is almost complete, what do you notice? You will note, of course, right, that you no longer see the evolution, right, of that, of course, gas. So I'm going to keep on adding with stirring to make sure that I have converted all of the calcium carbonate to calcium chloride. Notice, of course, right, that that sand is pretty inert. That sand is not reacting, right, with calcium chloride. With HCl. Okay, so now I've added all the complete, of course, volume, of course, of hydrochloric acid. There's no more fizzing, so I know that reaction, of course, is what? It's complete. But what do I now have? Right now, of course, I have what? I have my solution, right? So here's my solution, and that solution is a solution of what? Calcium chloride. I cannot discard that solution. Why not? Because I need to then, of course, work on that solution later so that I can recover, right? I can recover the calcium carbonate. So again, I'm going to allow this to settle. I'm going to pour that solution off, right? So I'm going to remove that solution by decantation. And inside, of course, my evaporating dish will just be, of course, the sand. And inside, of course, my beaker here will be my solution of calcium chloride. Alrighty, so here we go. Now that it's settled, I'm going to slowly pour off. Hopefully you can all see this. I'm going to pour off my calcium chloride solution. And inside my evaporating dish, right, what do we now have? It's just sand. However, this sand certainly is contaminated, right, with, of course, that HCl solution. And so in chemistry, right, we use a term called washing. And all that means, of course, right, that we add a small amount, of course, of a solvent, usually water, right? And I'm using water because HCl is water soluble. So we just wash just to make sure, right, that we remove any excess HCl, right, molecules that might be adhering, of course, to our sand. Again, I'm going to take this solution and I'm going to transfer it. Hopefully it's settled. And I'm going to transfer it again, right, to my calcium chloride. Beautiful. And so now, in this container, what do we have? Well, this is, of course, water, calcium chloride solution inside my evaporating dish. is my sand, which is hopefully we've removed all, of course, around HCl molecules. But we're still not done as yet, because this sand, right, is what? It is certainly not dry. And so I'm going to be transferring that, of course, right, to my hot plate. I'm going to be placing this on top of a beaker, of course, of hot water, and allow this to dry. Hopefully, it will take approximately maybe 5 or 10 minutes. So now, just as a reminder, right, don't forget, of course, that right now we are what are we doing? We have in my container number 2, right, this is my salt water solution. We're allowing this, of course, to evaporate to dryness. And now I have, of course, a setup that contains, of course, what? A beaker, just a beaker with water, right? But on top of that, of course, is my sand that I'm going to allow to sit, right, to dry completely. Okay, so just to make sure that we're all on the same page, right, I need for you to take a few minutes and look back at your data sheet. And please do me a favor and record the mass of the empty container, right, the evaporating dish. So the mass of that evaporating dish is going to be 40.777 grams. So the mass of that empty evaporating dish, this is the evaporating dish, is 40.777 grams. Okay, so you should also notice, of course, right, that the water is that salt solution is beginning to boil. And so in addition to that, now I'm going to do my third setup. My goal now is to try to recover, right, my calcium carbonate. So here's my solution of calcium chloride. We need the solution. I'm going to place it also on the hot plate. This solution must come to a boil, and then we're going to let it boil for approximately 5 minutes. Once that, of course, process is complete, I'm going to go ahead and add our calcium carbonate, our potassium carbonate solution. That's also, of course, what, a clear, colorless solution. And of course, why are we adding, of course, the potassium carbonate solution? It will be to do what? To recover, right, our calcium carbonate. So remember I said that your calcium chloride will react with, of course, the potassium carbonate to regenerate or to recover, of course, right, our calcium carbonate solid. And that's, of course, a chemical process. So yes, so far we've completed several physical means, of course, of separation. We did extraction. We extracted, of course, our salt using, of course, water. We performed, of course, our filtration. We also, of course, did what? Now we're going through evaporation, and of course, we also, of course, performed a decantation process. Okay, so I'm going to allow this to boil, at least come to a boil for 5 minutes before we add the potassium carbonate. You know, and as I'm doing this, right, I always like to check to see if the sand is dry. And how do we know if the sand is dry? Well, the beautiful thing, we all know what dry sand looks like, right? So when I scrape the sides, right, so do you guys agree? So if I just take a few minutes and try to move that sand around, when it no longer sticks, right, to my, of course, stirring rod, then I will for certain know that that sand is completely dry. Right now it's still sticking a bit. Yes, it is moving freely, but I'm going to give it a few more minutes to come to complete dryness. Alrighty, so if you pay close attention to my calcium chloride solution, you will see, of course, it's now actually beginning, of course, to boil. And I'm going to allow that to go. I saw a few bubbles a second ago. And so I'm now going to start, of course, timing for approximately 5 minutes. This has been boiling now for 5 minutes. And so using our tongues, I'm going to transfer this to a wire gauze, just to make sure we avoid, of course, damaging, of course, our bench tops. I'm going to allow that to cool for a minute or two. I will avoid using my hands. And of course, then I'll add, right, our potassium carbonate solution. Now, what do you think should happen? So let's do this slowly. So adding that potassium carbonate should do what? Hopefully it will be the case, right? What are we going to do? We're going to hopefully recover, right, that white, of course, solid, which of course is what? Calcium carbonate. So as I'm doing this, I'll take a minute and also just stir my solution along. And so hopefully you observe, of course, the formation, right, of that white precipitate of our what? Of our recovered, right, calcium, of course, carbonate. Okay, now, again, this is, of course, a wonderful suspension, so I want to make sure that I only, of course, obtain what? Just the calcium carbonate, of course, solid. So this will again involve, of course, right, an additional filtration step. So I'm going to take my solution over, back, of course, to my setup. And so what I'm going to do again, of course, is to come up with a fluted filter paper for that filtration process. But before I do so, I need just to go back and just to check to see, of course, right, if our sand is completely dry. And so if you take a look now, you can see what? Now I can actually freely, right, those sand particles are moving freely. It's no longer sticking, of course, right, to my, of course, stirring rod. And so I know, right, that that sand is now dry. So what should I do? It's going to be very important now. Please note, again, of course, that I transfer that hot, of course, evaporating dish, right? So I'm just going to transfer that dish to, of course, what? To my wire gauze and allow it, of course, to cool. Remember now, if it's hot, that will affect, of course, right, my final mass. So in order for me to recover, of course, the calcium carbonate, we will need to set up, of course, what, one additional filtration, right? So I've already pre-recorded the mass of my evaporating dish, along, of course, with my filter paper. And so please note in your data sheet, you want to record that mass. And so the mass, of course, of this watch glass and the filter paper is 102.445 grams. Again, the mass, of course, of the watch glass and the filter paper is 102.445 grams. And so what's next? Well, just as before, I'm going to flute, of course, our filter paper. First in half, then in a quarter. I will move 1/4 of that, and using my tap water, no, not tap water, I lied. Using, of course, distilled water, please. I'm going to try my best, right, to hold that paper in place. Alrighty. So now that that is in place, right, I'm going to begin, of course, the setup for filtration. It's going to be a bit challenging this time to do this setup. Please note, right, without transferring any of the solid, but I'm going to try my best, because if I add too much solid, it's literally going to clog, of course, the paper, and make it, of course, this process, right, a bit more time intensive. Alrighty, so in this filtration process, please note the calcium carbonate this time around is my residue, so that will remain, of course, on my filter paper, and then later, of course, we'll allow that paper to dry. Okay, so I'm going to use, of course, my stirring rod to aid me, of course, in transferring my solid. Of course, this time around, of course, we have what? We now have a solution, right, of potassium chloride. I no longer need that solution. All we will need, of course, is to record the mass of the dried calcium carbonate. So this filtration process will take a few minutes as I try to avoid transferring any of the solid, right, to the paper. Alrighty, so again at the end, remember what I said to you earlier, the goal hopefully is that we recover this as much, of course, right? It'd be nice to get 100% recovery. And if you do, there's a good chance that your compound could be wet. So that doesn't mean you're perfect or I was perfect. However, of course, there is still solid remaining, of course, in my beaker. And so with the aid, of course, right, of the distilled water, what do? Well, we hold, of course, that beaker at an angle. And of course, using our squirt bottle, we just transfer all that solid, right, to the filter paper. And so at the end, it's making sure that I have perfect technique here. All the solid should be transferred, right? And now, of course, I'll just have to wait for the filtrate to go through and for us to then take a look at our solid calcium carbonate. Alrighty, so now that the filtration is complete, I'm going to remove my filter paper. Do not forget, of course, that I already have the mass of the watch glass, right, and that filter paper. I'm going to transfer that filter paper with the calcium carbonate solid to my watch glass. And just as a means of observation, right, you should be able, right, to observe that white solid on that filter paper. I'm going to take this over now, of course, to our hot plate and allow this to come to dryness. Alright, so this was just like with our sand, right? We're going to allow, of course, the filter paper to dry. And then at the end, I will, of course, report out, of course, the mass of the filter paper, of course, the watch glass, and the calcium carbonate. Okay, now, here's some information that you will also need. So, what I did a few seconds ago, of course, is I determined the mass of the evaporating dish plus the sand. So, don't forget that the sand was in that evaporating dish, and that mass is 41.612 grams. So that's the mass of the evaporating dish plus the sand. It is 41.612 grams. I'm not going to allow, of course, the water to completely evaporate so we can get the mass of the salt, and allow, of course, that paper to dry so that we can determine, right, the mass of the calcium carbonate. Alrighty, so now you should be able to observe, right, that the salt is completely dry. And so as expected, of course, right, it's just a white, of course, crystalline, of course, solid. Likewise, of course, you should also be able to see, of course, that the calcium carbonate, that white solid calcium carbonate, is also completely dry. Right, so here's a bit of it that I've removed, of course, from the filter paper. And so here, of course, is the final data that you need to record. And so the mass of beaker, this is now beaker number 2, with, of course, NaCl is 94.334 grams. The mass of beaker 2 that has in the salt is 94.334 grams. If you recall, you know the mass of this empty container, right? So you should be able, by differences, find the mass of that salt. In addition to that, you also know the mass of the watch paper, right? The watch glass, and of course the filter paper. And so again, now you have what? I'm going to give you now the mass, of course, of the watch glass, filter paper, and the calcium carbonate. That mass is 102.737 grams. So the mass of the watch glass, filter paper, and calcium carbonate, your white solid, is 102.737 grams. And so again, by differences, you should be able to report, right, the mass of the calcium carbonate. Alrighty, so I'm assuming now that you've recognized that we've isolated all 3, of course, components using several physical means, of course, of separation. But in addition to that, of course, we did use, right, 2 chemical means of separation.